This is the problem that we chose to solve.
In order to solve this problem, we will need two main concepts or formulas. The first, as stated in the problem, is the binomial expansion, and the second is the moivs.
Using binomial expansion, we can rewrite the quantity 1 plus I to the power 2n. Because 1 to any power n equals 1, 1 to the 2n minus r must equal 1 no matter what. Also, we know that I squared equals negative 1 and I to the fourth equals 1.
Since we know that I squared is equal to negative 1 and that I to the fourth is equal to positive 1, we can factor out I squared and I to the fourth in these terms in order to further simplify the terms in the expansion, specifically by changing the sign of certain terms by multiplying it by a negative 1. As a result, some terms in the expansion will no longer be imaginary.
Next, we can convert the complex number 1 plus I to polar form. The modulus of 1 plus I is root 2, and the argument is pi over 4. Therefore, 1 plus I in polar form is root 2 cosine pi over 4 plus root 2 I sine pi over 4. Using de Moivre's theorem, the quantity 1 plus I to the power 2n equals 2 to the n cosine n pi over 2 plus 2 to the n I sine n pi over 2.
Since the same statement was expanded using two different methods, which are the binomial theorem and the moivs, we know that these two are equivalent. We also see that there are real and imaginary parts on both sides of the equation, meaning we can equate real and imaginary parts. By equating the real parts, we are able to prove the statement given in the problem.